Alright, today in class we learned how to do geometric sequences. We talked about arithmetic sequences being something that we add or subtract to find the next term. So today during geometric sequences we're going to talk about what we have to do to find, first of all, the next three terms in a sequence, how to find the nth term of a geometric sequence, and then we'll learn how to write the equation of an arithmetic sequence. So a geometric sequence is a sequence in which the ratio between successive terms is a constant. So if I give you, for example, a sequence 1, 2, 4, 8, if we talk about a ratio, let's talk about that first. A ratio a lot of times is like 1 is to 2. You can write it 1 is to 2, or you can actually say 1 is to 2, or the last way that which we will use is you'll write it as a fraction, 1 is to 2. Now, when we talk about successive terms in a geometric sequence, we talk about 2 is to the term before it 1. We can also say 4 is to the term before it, which is 2, or 8 is to 4, the term before 8. And as we look at these, that's how you get successive terms. We look at these, all of these should give us the same value, and in this case it's 2, and that's where that constant comes from. Now if we look at this sequence, we have a sub 1, a sub 1r, a sub 1r squared, a sub 1r cubed, all the way out to a sub 1r to the nth. We're going to take, say, these two terms, and we're going to look and see if we get that constant. So if we make or take the ratio, we would say a sub 1r is to a sub 1. As you notice here, these a sub 1's would divide out, and you're left with r. Well, I'm going to take the next two terms and write the ratio. A sub 1 r cubed over a sub 1 r squared. The a sub 1's divide out, and then you have r cubed divided by r squared, which is just r. So we can see here that that ratio is constant. If it is not, then it will not be a geometric sequence. The common ratio is actually that ratio that we get between successive terms in a geometric sequence. It's found by dividing any term by its previous term. So I think I had this sequence earlier. So you can either find that ratio by taking these two, 2 divided by 1, or those two, 8 divided by 4. Either way, you'll get a 2. Or you could take these middle two terms, 4 divided by 2. So any pair that you take can divide, as long as you take any term divided by its previous term will give you that common ratio. In example 1, we're going to determine whether each sequence is arithmetic, geometric, or neither. So as we look, if we take negative 4 divided by 1, is this equal to 16 divided by negative 4? And is this equal to negative 64 divided by its previous term, 16? You can see that all of these give you negative 4, so that will conclude that it's geometric. And we're going to say that the common ratio r is negative 4. On B, we can see that it's getting bigger, but not by multiplication, so we're going to see what's going on. It looks like it's adding 6 there, adding 6 here, but it does not add 6, it adds 8 there. So because these aren't constant, it is not arithmetic. We're not multiplying or dividing, so it's not geometric, so we would say neither. There is no common difference. There is no common difference or a common ratio, so it's neither. As we look at the last example, we have 128 divided by 256. We can see that it's getting smaller really quickly. So we know it's not subtracting, so we're going to try this dividing. We're going to see if this ratio is the same as 64 divided by 128, and if it's the same as 32 divided by 64. You can then see that all of these will reduce to 1/2. And so because they all reduce to that same fraction, we can say that this is geometric, and r is 1/2. On example 2, it wants you to find the next three terms, and I know you don't need this, but I'd like you to identify what r is. So on this first one we can see that it's multiplying each term by 3, or we could take we could take these two terms and divide them 9 divided by 3 to get this number. If you can see what it's multiplying by, you can just state it though. And then to find the next term, you take 3 times 9 to get 27, and then 27 times 3 to get 81, and 81 times 3 to get 243. Okay, on B, again, you're looking to find out what that common difference. You can take these two and divide them, or not common difference, common ratio. And this gives you -5, so R is -5. To find the next term, you take -75 times 5, which is 375. Then we take 375 times -5, and we get -1,875. And we multiply that term by -5 to get 9,375. Okay, our formula for the nth term of the geometric sequence is a sub n equals a sub 1 times r to the n minus 1. So this a sub n, this represents the nth term. So if I say we're looking for the 17th term, we would say a sub 17. A sub 1 is your first term in your sequence, and you should be able to pick that out. The r stands for the common ratio, and this n comes from here. So if we had a sub 17, it would be 17 there. On example 3, it wants you to write the equation for each geometric sequence. So there are really two things that you need to be able to write the equation. The first thing that you should identify is your a sub 1, and that's your first term. So in our case, it's -6 on A. Then you're going to look for that common ratio. What is it multiplying by, or what is it dividing by to get to the next term? So here we can see it's multiplying by -2. And then we can write the equation a sub n equals a sub 1. In this case, it's -6 times r, -2 to the n minus 1. And we had a conversation about, can we multiply those two terms? Will it just become 12 to the n minus 1? Is that equal to -6 times -2 to the n minus 1? And you should come to the conclusion that these are not equal. We substituted 4 in and used 4. So we got 12 to the 4 minus 1, which is 12 cubed, to see if this is equal to -3 times -2 to the n minus 1 is 3. And if we do this first, that gives you -8 times -6 is -48. 12 to the third is 1,728, and you can see that these two terms are not equal. So, all of that to conclude that we cannot multiply these two numbers because of the exponent here. So we're going to leave it as that. The only thing I would show instead is that you can put parentheses, hopefully to remind you there not to multiply those two values. So again, the first two things on B that you want to identify is your a sub 1. Your a sub 1 is our first term, which is 1 in this case, and your r. So what are we doing to get from the first term to the second term? It looks like we're multiplying by 1/2. So r is 1/2. And then to write the equation, a sub n equals 1 times 1/2 to the n minus 1. And again here, I'm going to use parentheses to show that we aren't going to multiply first. We're going to do our exponents. Okay, on your last example, it says find the 12th term in the geometric sequence. So, you could find out what's happening to each term, what's our r value. And if you look, you can see that it's multiplying by -2, and then you could actually take -8 times -2 and then multiply that by -2 and multiply that by -2 until you get 12 terms. Or you could use our equation, which says a sub n, in this case we're looking for the 12th term, is equal to a sub 1, our first term is 1, times r, which is -2, to the 12 minus 1. And then we just have to solve that. We really don't need that 1. If it were any other number than 1, then we would need it. But since it's a 1, I'm just going to go ahead and leave it out. So I have negative 2 to the 12 minus 1, which is 11. And we talked about if this is an odd number, then we get to keep the sign. So our answer should be negative. And when we take negative 2 to the 11th, we get negative 2,048. Okay, so when you get to these word problems, you want to identify things you can find. Like here we were able to identify n was 12. We could pick out a sub 1, and we could find r. If you can find those 3 things, that will help you solve those equations. All right, your assignment is 6-5 Geometric Sequences worksheet. Good luck.